the current in various arms of this network using node analysis method. Over here we see that is we have two junctions or two nodes. One is this node, the other is this node. So what we can do is we can give our reference potential to any of the nodes. Let's say we give this at, we call that this is at 0 volt. If this is at 0 volt and we can take this at X volt potential. Now we can say I1, I2 plus I3 that is equal to 0. That is how we proceed. That is I1 plus I2 plus I3 is equal to 0. That is also known as Kirchhoff current law only, based on conservation of charges, that this point cannot be a source of charges. No charge can accumulate over here. It cannot generate any charges. It cannot consume any charges. So I1 plus I2 plus I3 is equal to 0. We have taken this at 0 volt potential. So this is also at 0 volt. So this point is at plus 6 volt. Now what we are doing is we are primarily, when we say I1 plus I2 plus I3 is equal to 0, then after that we use Ohm's law, that is V is equal to IR or I is equal to V by R individually for I1 and I2 and I3, and we put the values over here and we get the answer. So if this is at 6 volt, this is at X volt, we have taken this as the highest potential, so current is flowing in this direction. So potential difference across the resistor is X minus 6. X minus 6 is the potential difference divided by resistance. Resistance is what? 4. So this is the value of current I1. Whatsoever current is flowing this I2, it shall be flowing in one direction and it's going to be with just one value only. So if this is, whether you find the current over here or whether you find the current over here, whether you find the current over here, the reading is going to be same. It is not going to be different. And if you have to find the current in this resistance, we have to know what is the potential difference across the resistor. So if this is at X, so this is at also X. This is negative terminal is lower to this by 10 volt. So if this is at X, so this is at X minus 10. So the potential of this is X minus 10. If you look at the ends of the resistor, so one is at X minus 10, the other is at 0 volt, and we have taken current flowing in this direction. So potential of this is greater than potential of this. So the potential difference between the two ends of this resistor is, if we are interested in finding I2, so it is X minus 10 minus 0 upon 2 is the current in this. So if this is at 0 volt, so it means this is also at 0 volt. So this is at plus 4 volt. Now looking at both the ends of the resistor, one is at plus 4 volt, the other is at X volt, and we are taken the current in this direction. So X is greater than 4. So the value of I3 is X minus 4, X minus 4 divided 2, and that should be equal to 0. Once you solve it, you will get the value of X as 34 by 5 volt. And if you have to find current I1, so I1 is 34 by 5 minus 6 upon 4, that is the value of current. So that comes out to be 34 minus 30 upon 5 into 4, that is 1 by 5 ampere. We find the value of current in this arm.